Good morning, everybody. Happy Saturday morning. This is the last of our live STEM science shows. We've done 6. Hopefully it's kept you busy. Now you're all back at school. And we thought this week we would talk about how cold it is in New Zealand. If you are living in the South Island of New Zealand right now, you are going through some very, very cold weather because it's winter. And so we've had lots of questions this week about cold things and why it's cold. And so I thought today we would talk about the science of cold temperatures. And we also have a fun experiment. So if you want to do this experiment, you'll need to get a few things ready. You will need some salt. I have a whole bag of salt here. You're gonna need an ice cube. Go grab an ice cube from your freezer. You're gonna need something to put your ice cube on so you don't get too wet. I just have a plate here. And then you're gonna need some string. I have some string. I also have some scissors so I can cut the string. You're gonna need a length of string that is, let's say that long, maybe 10, 20, 30 centimeters, something like that. So grab string, scissors if you need to cut your string, an ice cube, something to put it on so the table doesn't get wet, and some salt. There you go. If you don't have those things now, go grab them. I'll open up my salt and we will be coming back to this experiment, so don't panic if you don't have them yet. You'll have at least 5 minutes to go get the things. Right, so while you're getting those things, why don't we look at what questions we have had in from you this week all about cold temperatures. Let's start with question 1. Why does my nose always run when it's cold? Great question. And when we talk about running, we're not meaning running off your face. We're meaning running as in you'll get lots of what's like a liquidy snot dripping out of your nose. And that is a really good question. So you may have noticed when you pick your nose, there are lots of different types of snot. There's the very watery, runny one that you get when it's wintertime and you're outside. And then there's big green bogies, which are disgusting. We're not going to be talking about those ones today. We're going to be talking about the running ones. Now, if you've noticed, if you've gone out in really cold weather, you may notice that the end of your nose goes red. And the reason why the end of your nose goes red in the winter is because your brain knows that it's cold and it rushes blood to your nose, and it has one job. And the job that it has is to warm up the air. So when you breathe cold air in, or when you breathe any air in, before the air gets to your lungs, it needs to be moist or wet, and it needs to be warm so that it doesn't irritate the lung cells that you have in there. And the way that that happens is you have a very long tube that starts at your nostrils and goes into the back of your head and all the way down into your lungs. And the whole job of that is, number 1, to make sure there's no bacteria or nasties or dust. And the way that that happens is, you may notice if you look in your nose, you've got these nose hairs. And the goal of the nose hairs is actually to try and prevent some dust and particles from going into your lungs. And then the side of your nose produces this mucus, which is like a sticky, watery substance. And the point of that is, number 1, to hydrate the air that goes in so that it's nice and moist when it gets to your lungs. But number 2, to get any bacteria or any viruses to try and stick to your nose so that they can come out when you sneeze. So in the winter, what's happening is you need to warm up the air lots and lots before it gets to your lungs. So your brain tells all of this blood to flow to the end of your nose will turn red. That's because the vessels dilate, which means that they're much warmer and they're bigger, so they can warm up all of that air. So the air that gets to your lungs is nice and toasty and warm. There you go. Next question is, hold on, we've got a question from Kurt Marshall. Why is the South Island colder than the North Island? That is a really good question. We're actually going to come to that in one of our next questions. So let's get our next question first, and then I'll put them all together. Next question is, why does rain freeze on the ground but rivers don't freeze? Good question. And actually, some rivers do freeze. Not common here in New Zealand, but if you go to Siberia, for example, there are some frozen rivers. So the reason is, you may have noticed when you go outside, if it's been freezing temperatures overnight, you get ice on the ground, or maybe you get little dewdrops that are frozen on top of the grass blades. And that's because it's a very small amount of water. It's either a water drop or a very thin layer of water, meaning it's very easy for the whole layer to freeze. Rivers have what we call turbulent water, meaning that the water is moving. And when the water is moving, you get this energy. And the energy is a potential energy that converts to a kinetic energy as the river moves. And that constant movement makes it very hard for ice crystals to form. And you need ice crystals to form into big, thick sheets of ice for something to freeze all the way through. So that means you need to have very cold temperatures and you need to have as little movement as possible. So rivers tend not to freeze as much as lakes will freeze because lakes tend to be more static or still water. But some rivers do freeze. And actually, if you've ever seen or heard of a glacier, most glaciers are actually frozen rivers that have got so cold, they've frozen pretty much all the way through. Now, if you do look at some video footage of rivers that have frozen in Siberia or lakes that have frozen in the winter, you may also know that they look frozen all the way through and you can see people drive on them and jump up and down on them, but right at the bottom, they're probably not frozen all the way through. There's probably still a little bit of unfrozen water, and actually that allows life forms like fish and creatures to still live in what seems like a frozen lake all the way through the winter. Next question. Oh, hold on, before we get to the next question, we have a YouTube question that is from Emily, who is 8. Emily wants to know, how does a thermometer work? Like, how does it know the temperature? That is a really great question. So, old thermometers, and the thermometers we're talking about are ones that have a bulb in them. They usually show the temperature in red. What happens is they have a very special liquid inside them. And that liquid, you may have noticed that when things get hot, they expand, and when things get cold, they contract or get smaller. And so that liquid is calibrated into a thin tube so that depending on how much it is expanding based on how hot it is, or how much it is contracting based on how cold it is, it's calibrated to show that on a scale, which then we measure as the temperature. So it's all to do with how things expand and contract, especially liquids, when they are hot or cold. And we can put that in a tiny tube and then it will tell you the temperature. All right, here's our next question. Where's our next question coming from? It is a question coming from home. How do animals stay warm in the winter? Great question. Well, it depends on the type of animal. So there are some animals that live in really cold places, and you may notice that they have a really thick coat. So some animals use insulation by having thick coats on top of them. And usually those animals have two types of coat. They have what's called guard hairs, which are the fluffy ones on the outside, and underfur, which is the thick one on the inside. And those two together, it's a bit like us wearing like a jumper or a sweater and a coat on top of that. Having two layers actually helps to keep us warm. So some animals have fur. Polar bears have fur, and the fur has a hole in the middle of it, so it's hollow in the middle. And that fur having a hole also traps more heat in there. So fur is one of them. The other way that some animals keep warm, especially those animals that go into cold water, like walruses and seals, they have something called blubber. And blubber is basically a big, thick layer of fat, and that can keep them warm. I'm going to show you a bit of a messy experiment, so it's not one to do at home unless you have permission, of how you can make your own blubber and actually show this experiment. So I'm going to take some water here. Here is some water. I'm going to take some of my ice cubes to make my water cold. Okay, so I've got cold water here. Now, if I was just me going for a swim in some very freezing cold water, I would probably feel very freezing cold. So I'm going to take my naked finger and put it into the cold water. Ooh, and it is very cold. Now, imagine I am a walrus or a seal. I'm going to need some blubber, and blubber is fat. So I'm going to make some fat out of this. This is just margarine. What I'm going to do is I am going to cover my hand, put it into a bag so I don't get covered in margarine, and then I'm going to slather my finger in margarine. So now my finger is covered in fat or blubber. Next, I am going to put it into another bag so that I don't get my water all disgusting and wet. I'm going to wrap that around there. Okay, so now I have a fat-coated or blubber-coated finger. It feels disgusting. Now, what do you think is going to happen when I put it into the ice-cold water? Do you think it's going to feel cold? Well, we can do this. I'm going to take my naked finger and my blubber-covered finger. I'm going to put them both into the ice-cold water. Whew, and this one is freezing. And this one, I can't even feel the temperature difference because the fat layer has insulated my finger and protected me from the cold. And that is how some sea mammals like walruses and whales and others have this blubber to keep them warm even when the water is really, really cold. And that is a really fun, a little bit messy experiment if you want to do that one at home. So there you go. Next question. Who's got another question for me? Why? Oh, we've got one coming from home. Why is it colder in the winter? Good question. And this goes back to the question that we saw before about why is it colder in the North Island versus the South Island? It's all about the Earth. So at the top and the bottom of the Earth, there's something called the North and the South Pole. And the temperature that we're at depends on how far away from the sun that we are. And you may know that it takes 365 days to go around the sun. So what happens is as we go around, people think that the North and the South Pole are directly on top of each other, but they're not. The Earth is slightly tilted. And so what that means is there are periods or seasons when we are closer to the sun in our summer, and there are periods or seasons when we are further away from the sun, which is when we're in the winter. And typically in those times we get less daylight and we get lower temperatures. Now there's also this thing in the middle called the equator, and depending on where we're positioned around that also looks at our distance from the sun. So basically if you're closer to the sun, the weather is going to be warmer. And in New Zealand, the North Island and the South Island, the whole of New Zealand is very long and thin, meaning that we actually span quite a lot of distance. And so parts of New Zealand are typically going to be warmer at the top and typically colder in the south based on how much the Earth is tilting and how far we are from the sun, as well as what season it is. And so in New Zealand, it's great because we have 4 seasons. And so we can tell our position and the tilt on the Earth depending on what the season is too. So there you go. Any more questions coming in? Let's have a look. Why do we get colds from being cold, Alyssa? It's a myth. We don't. So it's not the temperature that makes you cold. Typically, you get a cold in the winter when the weather is cold because more of us are inside and together. And some viruses actually survive better in different temperatures. But it's actually a myth, because my mum used to say, don't go outside with wet hair because you'll catch a cold. And I used to be like, oh no. But a cold is actually the common cold, which is a virus. And having wet hair doesn't mean that you can catch a virus. But having wet hair actually is probably not a good thing because you'll probably chill a little bit more, meaning your body will have to work harder to stay warm. So it's actually the fact that when we have cold weather, we tend to congregate more, we tend to be more close to each other, which is how bacteria and viruses spread, that we have more common colds in the winter than we do in the summer. Okay, I think we have one more question coming in. Hi, Nana Girl, how long have you been a scientist? From Chardonnay. Hey, Chardonnay. I've been a scientist for a really long time. Actually, I studied science at school and then I qualified in something called engineering, which is where I used all of my science skills to build things and invent things and make things. And so I have been working in the science and engineering field for over 20 years. It's a really long time, but even longer than that. Because if you've ever asked a question or picked up a rock and looked underneath something or tried to figure out how things work, then that makes you a scientist too. So I reckon I've been a scientist since I was a child, which is a very long time ago. And so how long have you been a scientist for? Do you ask questions? Because that makes you a scientist too. Okay, I think those are all the questions we've got coming in. So do you want to do an experiment? Should we do the experiment together? Okay, so don't forget, you're going to need an ice cube, some salt, a piece of string, and a plate. Here we go. Let me get my things together. I have an ice cube. Ta-da! Shall I use a round ice cube or a rectangular ice cube? Let's try it with a rectangular one first. Okay, so you should be able to see my ice cube on the end here. So you're going to take your piece of string and you're going to cut it so it's maybe the length of your plate, maybe just there. Here we go, cut. Right, now I want you to try and pick up your ice cube with the piece of string. So see if you can pick it up just by putting it on top of the ice cube. So you might want to hold the string on top of the ice cube for a little bit. Can you pick it up? I can't pick it up. It's not working. So we want to pick this ice cube up. And this experiment comes from our kitchen science cookbook and it's called Fishing for Ice. So to go fishing for ice, we are going to need a magic ingredient, and that magic ingredient is salt. So I'm going to leave my string, can you see that? My string I'm leaving on top of here, of the ice cube. And now I'm going to add some salt. So you don't add too much, I'm just going to add a little sprinkle of salt, and I'm going to put that salt on top of where the string is touching my ice cube. Okay, put some salt on there. I'm just going to leave that for a little bit. Now you may have noticed, if you live somewhere that is cold, that salt is used all the time on the roads. And the reason being is salt actually lowers the freezing point of water to below 0 degrees C. And so what that does is it means instead of a thin layer of ice forming on the roads when it's cold overnight, which would be very dangerous if you try to drive to school in the morning because it would be very slippy, instead they put salt on the roads to melt the ice so that you don't have ice, especially what's called black ice, which is ice that you can't really see, so that your drive to school is much, much safer. So because it lowers the freezing point of ice, what hopefully is going to happen in this experiment is the salt is going to melt the ice that is at the top, right by where my string is sitting. And as it does that, it's going to turn into liquid water. But that liquid water then is going to come into contact with the ice below it and refreeze. And hopefully it's going to refreeze over my piece of string. So we're going to give this a go, and it doesn't always work first time, so don't panic. You might need to leave it a little bit longer or try it with a different piece of string. But you can see that I've got salt and I've got an ice cube, and we're going to see whether or not my ice cube has now decided to freeze to the plate. Hold on, let me give it a bit of a hand. Here we go. So the question is, and don't panic if it doesn't work, we'll just try it again. Can I lift this ice cube up with this piece of string? And look, I can. And you can see how it's refrozen because the salt has reduced the melting point and then the liquid has melted back on. And now that is how you go fishing for ice. And that is how you pick up an ice cube with a piece of string using the power of salt. So we have just lowered the freezing point. Now, if you want to do that at home, show me your experiments, take some photos, let me see. I love watching you guys do all of your experiments at home. And if you have any questions for us, or you want us to answer some things, or maybe we'll feature a show all about your questions, then don't forget to email us at superfans@nanogirlslab.com. Okay, so experiment done. We've talked about the winter, we've talked about freezing temperatures, we've even made some blubber. You know what it's time for? It's time for our quiz. Okay, are you ready? True or false? Here we go. True or false? Question 1. Water freezes because it's not wearing a warm coat. You know that's a silly question. Okay, that was just to get you warmed up. That is false. Water freezes because the temperature drops below 0 degrees Celsius. Question 2. Are you ready? True or false? 10% of the earth is always covered with ice. What do you think? What do you think? It's true! Most of the ice is located in the Arctic and Antarctica. Luckily, we don't live there, so it's not so cold. Final question, question 3, true or false? Antarctica is the coldest place on Earth. What do you think? True or false? Oh, that was Joe. That was Joe's face. True or false? We lost the answer, but don't worry, I know the answer. The answer is true. And the answer is eastern part of Antarctic plateau can reach -100 degrees centigrade. I'm sorry if you got a fright there. That was Joe who's on the camera behind here, and you got a whole picture of his face instead of the answer. Don't worry. Hopefully that has been fun. That is our last of 6 STEM live shows. If you enjoyed these, please let us know. We might start them again. We might do some summer holiday ones. We might do some winter holiday ones. Just let us know what you would like us to do and we will keep doing them. But for those of you who've tuned into all 6 of our episodes, thank you so much. I hope you've enjoyed them. And then we will see you next time. Bye.